because I want you safe. I also want to take the time, since you guys came here, I want to do something while you're here, but not as much as I had originally planned, obviously because of the weather, but just a little bit. I think you'll enjoy it because it ties in nicely with what we were doing before. It also ties in well with probably something that some of you guys do already at your houses. I always try to look, as hopefully you've noticed, for applications of what we're doing that you actually experience in your own lives. And I don't think this is any exception to that. And it came to me a few years ago. I'll explain how in a moment. Here we are. Here's the ladies. So it involves chickens. It's the same chickens you guys analyzed before, but we're not going to analyze their egg laying. We're going to analyze their ability to lay eggs. So we'll more on that in a second. Back up. So back up. There we go. So what we were studying last time, which was like a week ago, and I'm pretty sure what we were studying was probability distributions. I think that was the theme from last week. Did anybody try the quizzes this week? There were 2 of them. It's okay if you didn't. Did you try one of them?
First one, yeah.
The one with the coin flip with your friend?
Yeah.
Yeah, that's a fun one, huh? Your friend was a bastard at first, wasn't he? Your friend was a bastard, taking your money away from you on average. Yeah, and then you fixed it to fix it so you didn't. Good, good. And then what you were doing with that quiz essentially was you were being an actuary. You were being a Vegas odds setter or bet setter. You were figuring how much should I pay out for a game to keep the money flowing in. Where's that break-even point? It's what Eric, I think you called it a break-even point last week. Where's the break-even point on a distribution? And you had to calculate it. And I'm stoked to see, especially on that quiz, if you guys get knocked down for that question when you check Blackboard, I think Fran wants those quizzes. If she knocks you off for how you got the amount that made the break-even point, let me know. What a lot of students do is they just keep trying numbers until they find one that works, and I'm totally fine with that. But a lot of times she's not, and I tell her it's okay, but sometimes she doesn't remember that I tell her it's okay. So if you get knocked down points, let me know, I'll add them back in. And there's an algebraic way of doing it, which some of you may have discovered, but there's also a keep trying until you get it way of doing it, which works just fine. So anyway, let me know if you lose points, because I'll give them back to you. So anyway, the idea of today, and also Tuesday of next week, assuming that it doesn't snow apocalypse, whatever they're calling it, again, is extending the idea of probability distributions to something a little more concrete. So let me tell you a story. 4 years ago, yeah, it would have been March 4 years ago, so whatever that is, March 2010, we went into High Desert Ranch at home because we wanted to buy chickens. As we said, we lived in Bend 10 years, don't have a dog, we've got a kid. We have to do one of 3 things, 2 of 3 things. You have to have a dog, a kid, or chickens, otherwise they ask you to leave. So we don't want a dog, we got a kid, the 3rd thing is get some chickens. So we decided to get some chickens. We decided to buy 4. I sent Max in, I said, Max, go get 4 chickens. And it's really cute, they put them in a little box, like a Happy Meal. It's very, very adorable. There they are. Back up one more so you can see that box. They cost about $3 for the 4 of them, it's adorable. And the idea is, why are we getting chickens? Because ostensibly we want eggs, right? We want to get eggs because have you ever had like a backyard chicken egg? Oh my God. It's funny because last year, before we got the new ones, the old girls were getting old, they're laying less, so we had to buy a dozen eggs from Trader Joe's to augment our eggs. And I cracked one of ours and one of their organic, free-range, cage-free eggs. And I'm looking at the yolk, I'm like, our yolk is twice as big as that one. It's buttery orange. It's huge. I mean, I don't get it. I don't get it. What makes it different? And I'm guessing it's just they have free reign of the yard. I mean, from the time the garden shuts down in the fall, they're in the backyard running around catching bugs, catching frogs, catching lizards, being chickens, happy. Anyway, so we got Bertha, we got Mary, we got Marge, and we got Nancy, named after our 4 grandmothers. So brought them home. I got an Americana, an Orpington, a Delaware, and a Plymouth Barred Rock. FYI, if you keep chickens, anybody keep chickens? You guys keep chickens? You do. Tom, what kind do you have?
About one of each.
One of each.
Silver Wyandotte and a Barred Rock and a red and a, yeah.
A Rhode Island red.
Yeah,
we didn't get any of those for some reason. I don't know why. Max,
they got attitude. Ours is named Lil Kim.
Yeah. Lil Kim.
She's cool. She's head of the flock though.
Oh, she's the alpha. Okay, she's the alpha male because our Americana, Marge, was the D-bird of the ABC. She was like the bottom. She was the bottom of the pecking. Literally, watching the pecking order is kind of a fun thing to watch. Like it exists and it involves pecking. And it involves ordered pecking. It's pretty. I'm like, holy shit, they call it that for a reason. Mary was the boss, definitely the boss. Bertha is kind of this. She's the Plymouth Barred These are great layers. Orpingtons, Delawares, and Plymouth Bards, great layers. Orpingtons especially, very, very good. Very, very pleasant disposition birds. If you're thinking about getting them, you get a whole flock of them and be totally happy. So there they are set up at home. Max has set up the water and the food. There's the box. Yay! Got some more. Yay! Yeah, hi. Hi, you don't look happy, Gail. Sorry.
I drove from Madras.
You drove from Madras. I'll make it worth your while, I promise. I promise. I'll make it worth your while. I'm sorry. I promise. I biked from North Bend. Does that count? No, it doesn't count. So stop talking about the chickens. So anyway, recently, because the girls get old, and you did their egg production on your last exam, they do get old quickly. They lose egg production quickly. Like within 3 years, they're down to laying 20% of what they were laying when they were 6 months old. We got 4 more. Here's the new flock. So that's Mary full grown. That's Nancy full grown. That's Bertha full grown, and there's Marge full grown. We also picked up, I think that's Agnes. I can't tell anymore because, well, 3 of them are dead now. Agnes, May, Fern, and Gertrude. Mary killed May. We think it was because it was a pecking order thing. May have been a rooster. May have been a rooster, or Fern. Whatever, I can't remember which one she killed now because it was so long ago. Whatever one she killed may have been a boy and showing that aggressive sign. And as soon as we found that she killed her, because Jen actually watched her murder, kind of weird. We got rid of Mary. We put her with another flock. I should have made soup out of her, but we brought her to a different flock, and she immediately went after the roosters in that flock. So I'm like, okay, she's just aggro. She's like a big Kim. So we got rid of Mary, and so yay! This is way more than I thought it would come out. Thank you guys. So anyway, Fern got murdered. May and Gertrude both died in their sleep. I don't know what happened with them. They just kind of killed one morning while outside. They're laying in the bottom of the coop with their eyes closed, and they died peacefully. Agnes, sorry. Very, very cute. She has a horrible condition in her mind now because she watched one of her sisters get killed and watched 2 more die. So for months now, she hasn't laid an egg. All of our neighbors' chickens keep laying eggs. And I'm thinking to myself, holy crap, we got a rooster. So the one that made it of the 4 is a friggin' rooster. And that's what brings me to my discussion of what we're talking about today. Here's the original 4. I'll come back to Agnes in a second. I'll come back to her. Here's the original 4. And I walk into the store with Max. I go, Max, go buy 4 birds. Go get 4 birds, whatever ones you want. He kind of walks around, he picked these 4s, the ones he wanted. And we take them up to the counter in the little box. And I go, they're called pullets when you buy them in the store. Pullets are sexed girls. They've been sexed. And I was like, so how do you sex them? And he's like, well, they've got this very specific process, which he didn't explain to me. I was like, so are you always right? He's like, oh, no, it's not 100% correct. And I said, so how right are you? And he's like, 90%. We're getting right 90% of the time. And I looked down at the box and I said, that means there's a 1 in 3 chance there's a rooster in this box. And he said, what? And I was like, want me to prove it to you? He's like, yeah. And then the discussion that ensued made me realize this is the perfect thing to talk about with where we're headed next. It is a perfect way of describing the next step of 243, which is called the binomial distribution. It's a perfect example of how to get into that. So what we'll do today is set that up. And then we'll kick you out early so that we can stop keeping you here until the snow accumulates even more. We'll slow down, that's good. So anyway, let's talk about the information that we know from this experiment that led me to my 1/3 claim. So here's what we know. Let's skip forward here. This is what I was told by the guy at the store. If you buy a chick out of the bin that looks like this, it's so cute when you go to the store in like early March. Like hundreds, if not thousands of them in these stores, in these little bins. Little food dishes set up, heat lamps. They look like this. So what I did was I sent Max in there and I said, go get 4. And there were hundreds of birds in this store that day. I mean, we picked 4 varieties, but there were easily 10 different varieties of bird in the store that day. It was awesome. Rhode Island Reds were there. I know he didn't pick them for whatever reason. Leghorns were in there, but he got a Delaware. Well, I made him pick a Delaware actually because I'm from Delaware. So if I wanted Delaware, I had to. So, but anyway, my question really becomes is, how did I know it was 1/3? I guess that was my first question is, how did I know it was 1/3 so quickly? Anybody have an answer as how I knew it was 1/3 so quickly? Besides the fact that I'm a mutant and I think about this stuff all the time. But how was I able to extrapolate that, and I made a 1/3 come out of there? Is it at all obvious to you right now? It's okay if it's not. It shouldn't be as obvious because you don't think about this stuff religiously like I do. Any idea? It's okay. It's totally fine if you don't.
It's about a 30.9.
It's about a 30.9!
Is that a full no?
That's coincidence, actually. That's good. Speaking of which, thank you, Tom, actually, for a small aside. If you got a question wrong on the project, but you hadn't, I was nice I thought it was helpful to give you guys all the answers on that project, which I think was very helpful. Unfortunately, I didn't realize this until recently. A couple students got the correct number with wrong math. And so dividing 0.9 by 3 gets you close to a third, but there's actually 4 birds, not 3. But the point is, look at Fran's comments. Sometimes she doesn't catch those comments correctly. So if you're unsure about why you got marked off for wrong math, just let me know. And I can explain it to you in more than one sentence. Aaron.
Are we gonna, I know why.
Go back, tell me why.
Say why?
Yes, tell me why.
Because the probability that the female chick is actually female is sort of 0.9.
0.9, yes sir.
So 0.9 to the fourth is roughly 2/3. So 1 to the still 1. So there's a like 0.66. 0.6561 out of 1% chance. So reverse that.
Unfortunately, I don't think the camera picked it up. That was okay. We'll get to it. No, you guys, it was beautiful. What you said is exactly what I did in my head, but not with the precision you did. I said, what's 0.9 times 0.9? It's 0.81. That's about 0.8. Call it 0.8. What's 0.8 times 0.8? It's 0.64. 0.64 is about 2/3. The chance of them all being girls is 2/3. Therefore, the chance of there being at least one boy somewhere is 1/3. Now, that's very quick mathematics. Aaron, you picked it up. Fantastic. It's extraordinarily tricky to pick that up that quickly, though. So what I want to do today is walk us through that calculation to get to that. That'll be our in-class quiz. As a thank you for you guys for coming in. We'll get you an in-class quiz to do too. Okay. So what I want to do today is I want to answer a few questions. Like, for example, and Aaron, I think you made an assumption here. I want to make sure we're okay with this assumption. Did you assume that Max was sampling independently or dependently? It's okay if you don't remember this. You made an assumption by the math that you did. When you did 0.9 times 0.9 times 0. Think back to your last project. I know it's painful. You're trying to forget it. You were assuming independence, weren't you? So what you were assuming was, here's Max going into the store. You're very excited, right? He goes in to grab a bird. What's the chance that bird's a girl? 90%, 0.9, right? So if suppose there were 500 birds in the store. Just pretend for a minute there were 500 birds in the store. The probability is 450 out of 500 that he grabs a bird, that he grabs a girl, right? Fair enough, 0.9?
Yeah.
Now, when you said 0.9 times 0.9, that's assuming he put the bird back in, then shoveled and grabbed again. But is it okay?
It's close enough.
It's, say that again.
It's close enough.
It's close enough to assume independence. Think about why. If he didn't put the bird back in, and this is Mary. Mary's a girl. Put Mary aside. What's the chance the next bird's going to be a girl? Realistically, 449 out of 499. Because he took one of the birds out, right? He didn't put her back in. But what's 449 out of 499? With any kind of precision, hang on one second. Let's let Google answer that for us. My question is, was Aaron legit in assuming that's close enough to 90% to use? Yes. No! John says no.
No, I said yeah.
Oh, you said yes. I heard no. Because I have a solution. If you said no, that's okay. It's okay to say no. It's totally fine to say no, actually. You can calculate it without replacement with something called the hypergeometric distribution. But if you guys are cool with this, I'm down. Okay, so now there's 2 birds out, right? Assuming they're both girls, what's the chance the next one's a girl? Well, hopefully you see the pattern, right? 440. You're having nightmares about your last project, aren't you? Well, don't worry about it. Because we're not going... Is this close enough to 90%? Yes. We're not going to do it this way. We're going to assume they're independent because... And here's the guideline. If you ever need... Gallup does this all the time, just so you know. Whenever you read about a Gallup poll, they're doing the same thing. They're pulling chickens out of the store without replacement, but pretending it's with replacement. Because they're selecting like 1,000 Americans from like 330 million Americans or 200 million voting Americans. That's a small sample drawn from a big population, right? As long as you only draw a small sample from a big population, it's totally fine. Max pulled 4 chickens out of 500. That's a tiny sample. If you're ever worried about if a sample's too small or too big, just send me an email, I'll tell you. If you're like later on when you're drawing your own samples for your own research, just ask me. I'll tell you. There's a guideline that's used often, as long as you're drawing no more than 5% of your supposed population. That's what is too small? Exactly. And he's pulling, in this particular one, Max is pulling less than 1% of the population, right? he's pulling less than 1% of the population. So we can go ahead and assume that the independent assumption is legit. It's the same thing you guys did in your last project in developing the pumpkin seed germination rate, assuming it's always 40%. So many damn pumpkin seeds and you're drawing a small bag of them. You can assume they're independent. Independent math is always easier to do than dependent math, as you so painfully saw in your last project. Sorry. Okay, so what I want to do is I want to build up to Aaron's math that you just did. But let's build it piece by piece, because I haven't seen you guys in a week. It's been a long time. I want to revisit the idea of probability distributions while we're doing it. And then last but not least, if we have time, you know those programs that I gave you, but I doubt we'll have time today, and that's okay. So let's do a couple things at once. Let's do that review, and then bring it all the way up to